Okay, this question is asking you to draw line structures for all the constitutional isomers of C4H10 and C5H12. And so this is a little bit of a challenge because you have to be able to sort out all the different constitutional isomers. Now, for C4H5, there are C4H10, there's just not that many, right? So we have 4 carbons, and there just really isn't that many different ways to arrange 4 carbons. Turns out that there's only 2. And so in a line structure, we could say, all right, there's always going to be the structure where all of the carbons are arranged in a line. CH3, CH2, CH2, CH3. And remember that the ends of the lines and every inflection point is a carbon, and it is to be assumed that the carbons are fully surrounded by hydrogens, or they have a full octet. And if there's no other atoms that are showing, then they're assumed to be hydrogens. Okay, the only other option for C4H10 is to have a branch. And if I branch, then it has to come off the middle. This is the only way to get 1, 2, 3, 4 carbons in a molecule. And so these are the 2 constitutional isomers of C4H10. All right, so let's take a look. What about C5H12? Well, this is one of the things to think about, is that once we start adding carbons, we really increase the number of possible isomers. C2H, 2 carbons, there's only 1 possibility. 3 carbons, there's only 1 possibility. 4 carbons, now there's 2 possibilities. But when we get to C5H12, there's going to be 3 possibilities. And man, once you get to C6, 6 carbons, then it gets to be like 6 or 7 possibilities. And so we're going to do C5H12 for now. So there is 3 different possibilities. Again, the first possibility, 1, 2, 3, 4, 5, everything straight in a line. Now, to think about the different branching that's possible, it's probably beneficial to just move 1 carbon at a time. So for instance, I can take one of the carbons and then branch it off one of these other locations. So it's really important to remember that if I put the carbon here, this is C5H12, but I could, what about this spot? If I think about this spot and put it there, I would end up with something that looks like this. It's important to remember that these 2 structures are exactly the same. And so don't get hung up on forgetting about that. When I remember that if I just rotate this structure around an axis, then I go from one to the other. So they're not actually different constitutional isomers. It's the same molecule. So let's get rid of that one, because there's only 1 more now. And so since I tried this one, this location, and I decided that this location is the same as the other one, then it seems like maybe I could, excuse me, let me back that up. I tried this location and these 2 locations to put this carbon, and it ends up being the same molecule. So the only other option is to try double branching, and I can do that. I can go 1, 2, 3 carbons, and then I can get a double branch off of the middle. That'd be 4 and 5. And so here's the other constitutional isomer of C5H12. Real quick, just so we understand, 1, 2, 3, 4, 5, 6. Now we've got 1, 2, 3, 4, 5, 6. Look how things really get crazy here. I've got that guy, then all of a sudden I've got this guy. The next one is the same. So now we can do this guy. Oops. I can do this branch, then this branch. And so I continue to move into the number of isomers. So I think this is all, I went from 3 to 5, and then it goes like to 11. It goes up really fast. Okay, so this is what we mean by constitutional isomers. The important consideration here is to remember that it's easy to get confused when drawing these constitutional isomers, because you might think they're different, but they're not different. They actually equal each other. Okay.